We're going to look at transforming shapes, and those are translations, transforming shapes. My intentions were to get them to look at moving shapes around in an interactive way, so they could have a look at what they needed to do together, and I wanted them to be able to see it quite visually and hands-on. So what I was aiming at was, first of all, getting them to get an idea of where they needed to draw different lines and where coordinates are on axes, so they were familiar with where they might be transforming their shapes. And once they had done that, then I wanted to actually move them onto moving an actual 2D shape around using the particular lines that they'd identified.
Y equals X.
What about the line? Why is it?
I'm not sure. Right across. Is that what he's done?
Positive, I didn't know.
That's... Oh, I didn't know that. Y equals X.
X equals minus 2. It's only there, isn't it? So, no matter where you plot your X like that, it's always going to be X equals minus 2. Then it'll cross down, won't it? Yeah, but it's still X equals minus 2.
So we substitute, when we say y equals, where x is 1, what would it be?
1X.
You're just looking for 1? I'm just looking for 1. Yeah. Why would we be saying it's just 1 there?
Because you know what number it is.
Yeah, we know the number.
Because you know that the value is.
Absolutely, that's right. We know the number x is, so we say that y is 1 there. Say we looked at 2 and put that in, so x is 2 instead. What does y equal here? It's 2, yeah. So it's 2 going across and then up 2. Okay. There was quite a lot of recap and they were revising, but also perhaps changing their views on certain things. We were looking back at algebra and we went back to the basics of how that substitution method can be used to help them draw the line y equals minus x. Which brought up a really good point there with a minus minus, which they successfully said was a plus, so that was a real bonus. Just looking at it, can anyone tell us what the relationship is between y equals minus x and y equals x? Is there any other ideas with that?
Image, isn't it?
You see the mirror image. The whiteboards are well set out. Obviously, there's a lot of space on them, so we can use that, and not only just to put diagrams, but workings out as well. And they can stay on the board until the end of the session. Their work is on view, so they can all see what they've done in the lesson. And it aims at seeing all the way through the lesson how it's evolved. I'm just going to give you a handout on your tables, okay, so you can all see those. We've got transparencies and we've got shapes. Okay. That is the first question and the first position of your shape.
One to show where it started, and
Yeah,
one to
yeah.
show where it finished. So 3 across is 1, 2, 3,
So what is it? Is it?
and then it's
Oh.
going to be that.
I was hoping that they would understand the difference between translations, reflections and rotations, and also to be able to make some links between some transformations that end up moving an image in the same way.
So we put it in the right place, or we did.
We did.
And then it says, how could you write this as a translation vector? What does that mean?
Vector, yeah, okay. Has anyone any idea what a vector is? Anyone know?
Letters. So like X and Y, using your X and Y, isn't it?
It's normally x and y, yeah.
One point to another. So
Vector is from one point to another, so it's defining
where it's gone
that.
from it. Oh, I can't think of how to say it.
I think they are learning, especially earlier. There were 2 terms that came out. The vector term was completely new, so we did clarify that. And we talked about how coordinates can be then sort of moved on to what vector notation looks like.
Because basically, if it's in the positives, it's positive when it's going right, and it's positive when it's going up.
Yeah, when it's going down and left.
It's gone across to the right by 3.
Yeah.
And then it's gone down by 2. That's where we get the negative for the 2.
Yeah. Okay. Yeah, I see what you mean. So that would be on the bottom of the.
Working in groups allows them to come to conclusions together. It allows them to come up with their own ways of thinking about things and then challenge that. And also it enables them to explain more clearly and arrive sometimes ultimately at contradictory conclusions to the ones that they originally thought. But I think it allows them to solidify their knowledge and gain a deeper understanding of how the mathematical operations actually take place. It enables me to hear what they think. If I don't hear it, then I don't know. And if I do hear it, then I'm aware of how they are responding to a challenge. And it enables me to then conclude where they need to go next. They like to get involved at the front of the board, and they tend to share out the work like that because they like to work together. Is everyone agreed that that is where we have the first position?
Line equals minus 1. So it's going to be 2.
Looking then at reflecting it along that line, if you have a look at what they've done in this group, what do they think?
-3 and -4.
It needs to be on the 0 as well. Because if you see there, it's.
Because what we've just done before, wasn't it? Y equals -1 is on the line.
Yeah, but it's a different question. It's a reflection in the line. So if that was to be a reflection,
If that was a reflection, it would be like that.
it would be
And it's
closer
after-
together. Yeah. So that would be there. So it's 1, 2, 1, 2.
We've got the rotation, which is 180 degrees about the origin.
It's just if you stick a pin in it and just rotate it. You could use your compass and just move it round. It's caught.
You got it. Like that, isn't it? Yeah. Our problem was obviously with the origin being where we thought the origin was something different, didn't we? So. And then you
It's
obviously had
still
to
going to be
reverse
the
it.
same distance
Is it
from
going
the
to
origin.
move there?
It's going to stay there. So it's going to be, what, 180 round from that. It's going to be, assuming there.
This -1 and 4 would
Yeah.
be -1. And then I was thinking 4 up, but it goes off the scale. Because 4.
Do you think that's what the other groups are doing? I would actually get up and have a look what they've done. So up you get, okay? There were 3 girls working on a problem together, and they were coming to a conclusion about what they thought the translation vector had arrived at. So they were evidencing it by showing and demonstrating what they needed to do, which I confirmed, well, with a maybe, but try and ask what other groups think about it.
-1, so it's going left 1 and up 4.
You're going to show me?
So what is that? What's that? -1, so left, and then up 4, was it?
Yeah.
So 1, 2, 3, 4.
The aim of working that way was to get groups to look at other people's work and gain even more of a wider understanding of how other people think about the problem.
Basically, with y equals -x, x is
From
1.
left to right.
Y is going to be -1.
I can't see it.
If it's diagonal, though, it won't be completely opposite. It will be like that girl did it, where is this,
Say.
y equals -x?
Yeah.
I don't know.
It needs to be like that, but we need to speak to Chris because I can't remember how we got here.
Chris, do you know why it ends up like this?
Can you remember? Because yeah, so it starts off like that.
Yeah. And because it's y equals -x, your reflection line is going across that way, isn't
So
it?
it's like that, isn't it?
Yeah, so it's cutting through the shape. So when you flip that over, you think that point goes to there. So you put your ruler back on and you can see your reflection.
If you could just sketch where you think the original image will be after the reflection in the line y equals minus x. This piece of work will go on to a bit further involvement with transformations around other points on the axis, and it will lead to their own creations of transformations where they would fit and how their diagrams will look after those transformations. Then it leads on to actually having a go at some worksheet practice, which is inevitable. They need to see that they can all do individual activities themselves. Then we will move on to enlargements, which comes after this set of transformations, and we will look at how you can evolve a shape into a either bigger or smaller shape.